Good morning, good afternoon, and good evening, and welcome to the Friday Talk Show with Global Electronics and your host Rajiv Kulkarni. Right now, the time is 8:01 a.m. Central Standard Time of United States, and I'm based in Dallas, Texas. So, Global Electronics' main purpose is to bring the electronics community together, or the share to share the wealth of knowledge that we have accumulated for over decades and decades, and uh, to share the design, the process engineering, also the validation, the testing, and many more things which is pertaining to the electronics manufacturing activity. Every week we try to bring a new topic, and sometimes it is a sequel of the topic which goes into episode 1 and 2 and 3, because the topic is so vast that you cannot complete in one session. So we have been bringing a lot of guests with the tremendous years of experience that they carry with them in the electronics manufacturing activity, whether it is design, whether it's market intelligence, whether it is process engineering, or the quality and test methods. And today's topic is basically we are talking about the alignment of PDK, MDK, and the ADK with multi-layer technologies or multi-layer printed circuit boards or the design aspects. The PDK, which is process design kit, assembly design kit, which is ADK, and material design kit, which is MDK, they have a significant impact on multi-layer board reliability, ensuring silicon process accuracy, package assembly integrity, and material compatibility. Their integrated application minimizes risk, including delamination, warpage, SI/PI failures, and thermal stress, making them essential for high reliability multi-layer PCB and chiplet-based systems. Within design workflows for high reliability equipment and IPC class compliance, the PDK, ADK, and MDK triad functions as a modular reliability framework. While each kit functions as a rule library, their interconnection ensures that multi-layer boards can withstand electrical, mechanical, and environmental stresses. So, ladies and gentlemen, we have Mr. AmbaPrasad, who is a veteran in the electronics industry, being serving the electronics industry for more than 4 decades with his excellent design expertise that he carries. Let's welcome Mr. AmbaPrasad. He is based out in Silicon Valley of India, which is called as Bengaluru, which is a southern part of India, based in Karnataka state. AmbaPrasad, good evening. How are you this evening, sir?
Yeah, doing good.
Doing great, great, great. I believe Bangalore is getting chilly as an on and off, and at the same time, definitely Bangalore is also developing more and more now. A lot of investments are happening on the electronics, on the technology side of it. So let's get started on today's topic. Let me share my screen so that we can present your presentation. Hope everybody can see the screen. And here we
Contact.
go. And can you see the
Yeah, go to
screen?
full screen, full size.
Already is already done.
Yeah, yeah. Okay, done.
And so you can see the screen very well, right?
Yeah,
Okay. Okay, let's get started.
yeah, Rajiv, and welcome back, audience. A lot of repeat viewers. Basically, two things I want to announce here. Last week, since last 2 days, we had a AI summit in New Delhi. uh, the French Prime Minister, French President, Indian Prime Minister, and all who is who of AI are there in Delhi right now. The summit is still going on, and a lot of investments and announcements have happened overall in India. And as usual, a lot of things have come to Bangalore. All cutting edge technology has come to Bangalore now.
Yes.
So that's the latest announcement. And yeah, since I am conducting IPC course also since last 4 years, so to say, especially after COVID lockdown, let's say 22 onwards, each class I stress on AI. When we are having a talk on the corridor or in the coffee break, lunch break, when we talk to students, I talk about the influence of AI in electronic design, assembly, and even testing. So that is where almost for about a period of 3 days, about half an hour to 1 hour is spent on exchanging ideas with clients, and it is picking up. It is ramping up actually, the usage of AI. Yeah, that's it. Okay. To start with, we finished last session. This was the last page of last session. We were discussing how PDK, ADK, and MDK contribute on critical for functionality attributes. Then cross domain, we have to basically the IPC standards are IPC 2221 is laminar, 2222 is a vertical alignment, how it happens on a cross section of a PCB, and 6012 is acceptability of a PCB, rigid board. So these three, they not only triangulate, they cross connect. So just applying one standard will not work. So that's the whole idea. Yeah, though in the class we tell about this, but same thing can be articulated as alignment of PDK, ADK, and MDK. So same methodology, different naming. Yeah, that's how it is. Then if these three they correlate with each other and they gel with each other, then no problem. The product works like a magic. So we can go to next page, please. Yeah, this is what I explained. Alignment of PDK, ADK, and MDK uh, on critical for functionality attributes. And again, all the designs have to be compliant to IPC classes, class 3 or class 3A. Aligning a PDK process design kit with IPC 2221 and 2222. And again, correlating with IPC 6012F is a layered methodology. You map, you have to make a kit. As each kit, it has to be mapped to the parameters for IPC class. I mean, generally, the most of the audience here in our channel are class 2 and above, class 2, class 3, or class 3A. They have to go for a class level requirement and embed the DFM, design for manufacturability, design for assembly, and DFT. These three, if we triangulate, then we get a perfect cross connection and operationalize the compliance through audit-ready matrices. We can have a Excel-based audit. We can say we are compliant or non-compliant. So this is the whole idea. You can go to next page, please. Okay, this is a chart which we are taking as an example. If you look at 19 onwards uh, to 2019 to 2030, there is of course 2030 is a projection. We are somewhere in 2026. 2019 to 2025, 26, we are seeing uh, the growth in dollar terms, sales, say CPU and FPGA and APU, a graphic processor and ASIC. Now people call it as a XPU. That's it. Tensor processor, graphic processor. So that way. So now, if you look at very clearly, from 2019 to 2023, it is almost flat. The growth is flat.
Yeah.
And even the segmentation is not visible. But 2025 onwards, we can see things are doubling every year, almost doubling
Yes.
every.
Yeah.
So 2027, is the inflection point, because whatever we projected in 2030, what's going to happen may happen in 2027 itself, and take the technology by surprise, because you require some cooling period or something. Even enemy roadmaps, what they are projecting in 2030, some of the sectors like data center, 5G, and automotive electronics is definitely, it will be advanced. The implementation is going to be advanced. We cannot say that, okay, I have say 5 years of time, let me learning. The learning curve is going to be very steep and very fast, and what we are learned previously in 5 years, maybe now we have to learn and unlearn in 1 year. So that's
Yeah.
the meaning of that. Is how I decipher this chart. Next page, please. Yeah. So IPC class, when I say class, don't get confused between IPC class, which is a class 2, class 3, class 1, and this class. This class is more like a law point I'm talking about, how we advocate terms. IPC class, exact class reference, so you have to 2221B, 5.2.1, people can see what it is. Then there's a requirement summary. Then there is a design description, which happens in 2221, and requirement summary generally comes in 6012 standard. So this is how it comes. Then we have to map PDK, constraint manager, design rules, trace width, spacing, stack up, creepage rules, and all. In ADK mapping, we map footprint. Now we call it as a component outline, even with a step file attached, component 3D models, schematic, schematic versus layout, and coupon libraries. All test coupons are going to be a coupon library. They're stored as long as the product, especially class 3 and class till the product life of a product, the coupons are stored, and they are aligned to IPC guidelines, recommendations, and standards. So let me take a small breath here and tell what is guideline, what is recommendation, and what is a standard. Guideline is, even a OEM may say this is the guideline. It is just a guideline. They guarantee it works. Then, if the guideline becomes so popular, it becomes a recommendation. That is the next level. And almost the cross section of the supply chain and design, they use it, it can become a standard. So this is how the standards evolve. And MDK mapping, material design kit, material properties, supplier specs, and manufacturing tolerances. These are nowadays even uh, CAD packages like ANSYS, Cadence, they can import the data and store there in simulation files. And validation and verification, how compliance is validated, design rule check, electrical rule check, CAM attributes, simulation results, and lab test reports. And this is a totally 360-degree closure we have to take. Many people, they think that, okay, they say, I have very less DRCs in my board. Many people often confuse between DRC and DFM. DRC and DFM are totally different. Okay. So this is
Yeah.
what it is. Now we can have an Excel sheet where we say we are compliant, green tick, it is pending, we are not validated it, or non-compliant. It doesn't matter that we have to implement everything. It is a evolution, both a revolution, maybe in the next iteration or a next a recommendation become a standard, then yeah, it can shift left. So that's what it is. So next page, please. So this is a next page, sort of some sort of I tried to compress in one page. I realized it was confused actually. So class level traceability 2221, are we meeting all classes? Map PDK electrical thermal rules, trace width, spacing, creepage to IPC 2221C. Uh, or that's okay. I think it is a misprint. It should be C now. That I'll correct it. C is the latest standard. ADK libraries, what MDK, PDK does I mentioned. Next line I told what ADK does. ADK libraries embed schematic level compliance, material stack-up and shielding requirements, etc. MDK ensures material property alignment, CT mismatch, TG directory constant as a dissipation factor with IPC requirements. Then that is in 2221. In 2222, in a sectional design standard, PDK defines routing geometry, annular ring, pad via rules. ADK footprints validated against IPC 2222 tolerances, and MDK integrates laminate, copper file, solder mask thickness, solder paste thickness. So that's how the PDK, in some places, PDK takes precedence, in some cases, ADK takes precedence, but finally they have to triangulate. Compliance traceability, IPC 6012F, accessibility standard, performance and qualification. The MDK becomes most important. MDK operationalizes acceptance criteria, microvia reliability, plating thickness, peel strength, pull strength. Most of them are mechanical requirements. And especially in a CT mismatch, thermal cycling, that triggers misalignment or a delamination. So that's why it has to be accurate. Then the PDK simulation models validated as per 6012F reliability test requirements, and ADK embeds a test scope and templates for qualification. So that's how ADK, MDK, PDK, they become important in some other class. So in a laminar is important, on a cross section something is important, but in acceptability criteria everything is important. Yeah, next page please. Yeah.
Can you see the page?
Yeah, I can see the page. I am able to see the
Okay.
page. No. So
Okay.
here what I have done is I have captured everything in a table form. That's how your Excel sheet can look into. For example, an example, it can be even can run into sheets altogether. IPC class 2221B 5.2.1 trace width, requirement summary, minimum conductor width for current carrying. PDK parameter will be constraint stable, minimum trace width per ampere. ADK parameter will be footprint library pad to trace consistency. MDK parameter can be copper file specifications, thickness, current rating, and again solder mass, solder paste, etc. Verification method is DRC check and a supplier data sheet. So again, I have told everybody some of the examples I have taken. Clearance, again, whenever we talk of a width, automatically comes the clearance. They are inseparable. Okay, as long as two traces are there in a PCB, there is a width and there is a spacing. Okay, and then the same methodology. Minimum annular requirements. We cannot demand a 6012F class 3 with a class 2 design. So that they have to correlate. Pad and wire tolerances, minimum copper plating thickness. This is very much important, especially for class 3 and 3A boards. Conductor peel strength requirement. This comes from design kit. And thermal cycling. Nowadays, some OEM designs, they tell which copper to use. They are very clear about that because they have done their demo board with such and such a copper. In fact, they're telling you have to source from such and such a brand. So that's how it is working. If something cannot be implemented, that is work under progress. It has to be reiterated in verification and validation, and then it has to be flown back. Yeah, that's how. Even it may look even bigger. It can go to 5-6 sheets like this. Next page, please.
Okay, let's take a quick break here,
Yeah,
then we'll come back to the
definitely.
next one. Okay. Good morning, good afternoon, and good evening, and welcome back to the Global Electronics Talk Show every Friday that we bring in at 8 a.m. Central Standard Time of United States. So today's topic is alignment of PDK, MDK, and ADK with standard compliance. That is, especially in the HDI or multi-layer circuit boards. So today we have the veteran Mr. AmbaPrasad from Silicon Valley of India, which is Bangalore in Karnataka state, which is the southern part of India. So AmbaPrasad carries a wealth of knowledge for more than 4 decades in the electronics manufacturing industry, and he has been on our show on multiple occasions, talking about various aspects that involves in the electronics manufacturing industry. So, Mr. AmbaPrasad, let's continue our discussion. I will start sharing the screen again so that we can get on to the slide where we left. Here we go.
Go to next page, please. Yeah. What we saw so far was the definition, the problem statement, and then a matrix, a DRC matrix. This can be a checklist for release also. Now let's talk about DFM specifications, design for manufacture. When we say design for manufacture, it is for the PCB fabrication. For assembly, it is called as design for assembly. So, okay.
Yes.
When we go for a PCB manufacture, this was a use case which was done by aerospace company. Next 3 slides, we see what and what finally happened actually. So they went for a 3 bareboard flexible PCB vendors and 3 population vendors. Population means assembly vendors. They got the PCB. They sent for a DFM to 3 board vendors and 3 assembly vendors. So this is, since it is from UK, they're calling as a population. They call populating a board. In America, we call assembly of a board. In India also, we call assembly of a board. So, okay. So now they told these vendors they are using IPC class 2223 for flex to install and IPC 4552 specification for ENIC surface finish, which is again MDK. And 6013, 6012 is for rigid boards, 6013 is for flexible boards. And the 600H is a visual book, IPC standard, reliability rejection criteria. They told this is what our intentions are. Then trace via conservative, minimum trace width was 0.1 mm and 0.1 mm, that is 4 mil by 4 mil. The minimum via size is 8 mil mechanical drill on a 0.4 pad, and IPC spec for high voltage trace clearance. This is the specification. This is with what the design was done. And layer stack up and material choice, halogen free radiated hardness material, kept on cover layer for backside of a flexible region. Otherwise, on a rigid portion, it will be a solder mask for high voltage isolation. Solder mask on front side, and kept on was not possible because the components were there. So that's this is a problem statement. So finally, whatever is mentioned in IPC also cannot be met because there is a design requirement. Some place we can do, some place we cannot do. Then mechanical design requirements, tolerance discussed with manufacturers during the design phase, plus or minus 0.1 mm for body and 0.05 for dowels. So this is a requirement, alignment requirement. Full flex design on a 4x4 panel. Flex rigid would have helped more population because all flex boards will land up in a rigid region. I don't think there is a fully flexible board. What we call flex also only. The biggest challenge was tight copper specification. That was a design requirement, and the cleanliness after fabrication and after assembly. These are the 2 major requirements. And here, so they have gone for a 3 bareboard vendors and 3 assembly vendors. So in the end, we can go to the next slide. So this is what they specified in their design kit. effective copper thickness, sum of copper in all layers, normalized for a flexible footprint, bump stress analysis imposed on a maximum effective copper effect 31 micron, which is normally we can get with 1 ounce of copper, no problem. Power dissipation imposes a minimum of 20 micron. So that basically they wanted 21 to 31 microns of copper. This is the requirement. That is the by physics that much you require. Then on a top layer, minimum was 20, maximum was 25 when PCB vendors quoted and as a some microns. And the design was designed for 23 to 27, which they can accept 20 to 25. When the order was accepted, uh, see in the quotation cycle they told 20 to 25. But when it went to the order acceptance, people realized that now they have to have the PO on the table. It became 20 to 35. So now the vendor will say, I can give only 35. That's it. I cannot meet 27. Done. Then again, the internal acceptance, they flagged at 20 to 30. They took some average and they did it. This is the exercise. Then bond pads was 15. That's okay. No problem. Then the middle layers, ground 93% layout was covered by ground. So again, they are given the trace width, the copper thickness, 9 to 10 was what intended. 10 to 12 was designed for. They got 9 to 13.5. Again, they got a 9 to 13.5. Basically, unreaching. Unreaching was happening. Then the bottom layer, laser via was there. It is 20 to 25, 23 to 27 was designed. They got consistently 22. That it looks consistently. So it is consistently, it is the min-max window is almost consistent. Now what vendors say, you give a quotation, they say there is a bargaining for price. They say the sum result is not economically viable for a company to agree to go for a 20 micrometer after plating. It is not viable for them. Either they have to start with a thinner copper and spend more time on plating. More time on plating means more electricity bill on the PCB company. So that's how, that is a hidden agenda. You have to read between the lines. Then in a second tender, the company went for then they agreed to, they normalized their design. They gave some process variation. And then they told, if you go beyond this thickness, internal QC is going to reject. So this is the sort of a caveat. Internal acceptance on equivalent copper, but not on individual layers. Go to next slide, please. So these were the problem areas. You can see where they were getting the problems. The spacing, and there is a bond pad, there is a spacing issue, and then traces were moved by the PCB vendor. Then these were they were getting the problems. So trace etching, key to signal integrity, wire bondability, and assembly. Trace surface finish ENIG, key again wire bonding requirements. Vendor performs 100% AOI. Some vendors will do 100%, some will do 80, 90%, 70%. Again, institutes performance optical inspection at 100%. Alignment fiducials were unreached. That they have to reconfigure. Moved from F circle to cross. I mean the fiducial type F circle to they went to a cross fiducial. Then one batch was rejected. Then it was plowed back. Whatever the learning they have done. Then band powers were overedged. Bond pads were curved up. This became a wire bonding issue. Okay. The surface roughness on bond pads does not appear to degrade wire bonding through bond pads often rejected by module issues. So this is the problem they faced actually. Now how they solve the problem, I will tell you in the next session. So what happens is we do design, we do DRC, we do DFM, but a vendor equivalency is the biggest challenge in the industry. So this is the last slide. How they solve the problem, I'll tell you in the next session.
Absolutely, absolutely, absolutely.
That is a
Yeah.
10-pager.
Sure, sure. Absolutely. Yeah, yeah. So, Mr. AmbaPrasad, that's a wonderful presentation that you gave today on the PDK, ADK, and MDK alignment on with the standard compliance on the high density circuit boards. And to the audience, thank you all for watching. And just as a disclaimer statement, anything, any company's name or any authority or association name that we take, it is purely coincidental, or it may not be unintentional. So we don't intend to give any affirmative confirmation on that. It is purely just for the reference sake. With that said, Mr. AmbaPrasad, anything to the audience before we sign off for today?
What you said makes sense. There was a process called as advanced semi-additive process. So that became a brand also, that became a company also. So sometimes we have to say something which is the name of a company. The best example I can give is Indium. So whenever I say Indium,
Yes,
they get
that's
confused between Indium Metal and Indium Company. They get confused.
yeah.
So
No,
that's what
actually,
is
again, we do not intend to take any
Yeah,
company's
definitely.
name, and so that's a disclaimer. Global Electronics is not responsible for taking that company's name or any company's name for that matter. So we are here to provide all the technology knowledge that one has gained from their experience. With that said, thank you very much for everyone who is out there attending the show and supporting the channel. You continue to please subscribe the channel so that we have better subscribers, more subscribers actually, and also we can say more viewership. With that said, wherever you are, whichever part of the world you are, please do take care of yourself and have a good life and have a wonderful weekend with a good health. Thank you all. God bless.
Yeah, thanks. I think people should start commenting also. That is how we
Thank you.
learn
Yes.
and
Yes.
unlearn. Yeah, that's it. Yeah,
Thank you. Thank you. Thank you, Amba.